This video is going to cover topics 7D, H, and I, and that's solving quadratics with the quadratic formula, using the discriminant, and solving word problems with quadratics. The quadratic formula is this long formula that you've probably heard of that can be used to solve any quadratic equation. This is super helpful because factoring and taking square roots and all of the other methods that we've used don't necessarily help you solve every single quadratic, but this one works for imaginary solutions, real solutions, fractions, integers, irrationals, all of the above. So it's sort of like the last case resort that you would use. To use it, we need it to be in standard form. And standard form means your ax squared plus bx plus c equals 0. So it has to be in order and it has to be equal to 0. To use the quadratic formula, I like to label my a, b, and c because it's just sort of helpful for me. So in our first problem, a is going to be the 2 in front, b is the 1 that's sort of invisible and sitting in front of x, and c is going to be -5. So remember that the letters a, b, and c are standing for the coefficients. They're not actually standing for the x's themselves. So then we just plug it into our formula. X equals -b, so -1, plus or minus the square root of b squared, which is going to be 1 squared, minus 4ac, all over 2a. And then we simplify. So x equals -1 plus or minus. We're going to do all the stuff in the square root first. So that's going to be a 41 inside of the square root, all over 4. And now we try to simplify if we can. So in this case, I've got -1, and the square root of 41, let's think. 41 is prime, so that's done. So we've got plus the square root of 41 over 4, or x equals -1 minus the square root of 41 over 4. And you don't necessarily have to write it as two different answers, but I like to see it as two answers because it reminds me that there are literally two answers. There's the one where we add the square root, and there's the one where we subtract it. This next problem is not yet in standard form or equal to 0. So the first thing we need to do is subtract by 35 on both sides, and then we'll have 3x squared plus 8x minus 35, because the 35 doesn't have any like terms on the left, so it just gets tacked on at the end. Now we are going to label it. So my a is 3, b is 8, and c is -35. And we plug it into our formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. Sorry, it's a little squished. And then we simplify what's in the square root. So just to recap how we do that, if we follow PEMDAS, we would do 8 squared first, which would give us 64. And then we would have the -4 times 3 times -35. So inside of the square root, we are going to get 484 all over 6. And now we try to simplify. So 484 in the square root, I know that I can simplify that at least a little bit. It can definitely divide by 4, and we'll have a 121. And I know that 121 is 11 times 11, and 4 is 2 times 2. So this is actually going to be a perfect square. So we really have -8 plus or minus 22 all over 6, because apparently 22 squared is 484. So now when we break this down, we're actually going to get some nice-ish numbers, not irrational at least. So this is going to be -8 plus 22 over 6, or -8 minus 22 over 6. So the -8 plus 22 would give us, and that's 14 over 6, and in the bottom, -8 minus 22 is going to be -30 over 6. So this will simplify to be 7/3, and this will simplify to be -5. So our two answers are 7/3 and -5. Now I want you to pause the video and try problem number 3. Just remember that your first step is to get it equal to 0 on one side. So notice how this problem is going to have an imaginary answer, actually two imaginary answers, because i's always come in pairs. And because we have this negative in the square root, that is going to be what leads to the I. So when I went to simplify that, we got the imaginary. And this one, just to finish it, is going to be kind of crazy, because the sort of golden triangle, as some people like to call it, but it's just those three numbers can all divide by 2, so we can actually simplify this and divide all of the terms by 2. So I can divide the 2, and the 4, because all of those things have that common factor, and that is how it would simplify. So we'll get x equals 1 plus or minus I root 5 all over 2. So notice in these three examples that we have above, we had some imaginary answers, we had some real answers, but irrational maybe, and then we had some normal rational ones. There are always going to be 3 choices for the type of solutions for quadratics, but you're always going to have 2 solutions. So sometimes you have 2 different unique solutions, like in problem number 1 and number 2. But we can also have 2 imaginary solutions, like problem number 3. But there's also this option where you get something like x equals 2 twice. So that's called a double root on that same answer. So for our 3 choices, we could have 2 unique real solutions. We could have 2 imaginary solutions. And then we could have 1 double root, where it's like you got the same answer twice. So that one's sort of funky. 1 double root, we can have 2 unique and 2 imaginary. So we're going to use something called the discriminant in order to tell what types of solutions we have. The discriminant is b squared minus 4ac, and this comes from our quadratic formula. So if we look back at the quadratic formula, b squared minus 4ac, that's the part under the square root. So that means that if it's under a square root, if it's positive, greater than 0, then it's going to have 2 unique solutions. Because being greater than 0 means it's positive under the square root, you'll get the plus or minus, you'll get normal numbers. They might be kind of funky with irrationals, but you'll get 2 different things because of the plus or minus. If our discriminant is equal to 0, then that means the plus or minus, the square root of 0, is doing nothing, because the square root of 0 is 0, plus or minus, still 0. So that means we're just going to get that 1 double root when you have the discriminant of 0. And then lastly, if your discriminant is less than 0, that means it's negative, then your quadratic will have 2 imaginary solutions. Because if I have a negative underneath a square root, then I'm going to have imaginary numbers. That is the definition of your imaginary. So positive means 2 unique solutions, 0 means 1 double root, and then negative means 2 imaginaries. So let's see it in action. All we want to do for problems 4 through 6 here are find the discriminant and determine the number and type of solutions. So we're not actually going to find the solutions, we're going to just say how many there are. So the discriminant, we still talk about the a, b, and c, and we're just going to do that part that's from under the square root, but we're not actually going to put the square root. So I'm going to do the b squared, which is 6 squared, minus 4 times 9 times 1. So let's do this math. 36 minus 36, that's 0. If the discriminant is equal to 0, then we are going to get 1 double root. So the discriminant itself is not the solution. I cannot stress this enough. The discriminant is not the solution. It just helps you figure out how many and what kind of solutions. Problem number 5 is not yet equal to 0, so the first thing we have to do is subtract 4 on both sides. We get 9x squared plus 6x minus 4 equals 0. Now go ahead and try to find the discriminant. So this one we got negative 108 for the discriminant, which means we're going to have 2 imaginary solutions because the discriminant is negative. Try number 6. The discriminant is 69, and there are 2 real solutions to problem number 6 because we have a positive discriminant. Number 7 is a little bit different because I don't actually see a middle term. So we think of our standard form equation, and in this case there's an ax squared and there's a c, but there's no bx. So what that means is when we go to do our discriminant, a is going to be 6 and c is going to be negative 12, so that must mean that b is 0. There is 0x in here. So we're going to set it up as b squared, which is 0, minus 4 times a times c. And then when we do this math, we're going to get 288. So this is a positive number, so that means that we are going to have two real solutions because the discriminant is positive. I want you to try number 8 now. So I got positive 196 for the discriminant and two real solutions. Number 9 is just a little bit tricky because we have to expand it before we can actually find the discriminant. So that means we're going to keep that 3 out front and multiply x plus 4 times x plus 4. This is how we'd sort of follow PEMDAS and do this multiplication. Now you can distribute the 3 and then multiply the two binomials, but I'm going to actually FOIL them first and keep the 3 out front because I like to deal with smaller numbers. And then we can distribute our 3, so we get 3x squared plus 24x plus 48 equals negative 36. And we would add 36 to both sides. And now we can actually do our discriminant formula and see how many solutions there are. So I got negative 432 for the discriminant, which means there are going to be two imaginary solutions to this quadratic. And that's it for the discriminant section. Moving on to topic 7i, we're going to do some word problems. So the way that we do this is we just try to read it, interpret it, and then solve the quadratic. So it's usually going to make a quadratic, at least in this unit. So problem number 10 is find two consecutive even integers that have 164 as the sum of their squares. So consecutive even integers. That means we've got two numbers that are even that go back to back. So like 2 and 4, 4 and 6, 10 and 12, any even integers that come back to back. So what we want to do is think about how one of them can be x. We got some number x. The next even number after that is going to be 2 away from it. So it's going to be x plus 2 because 4 and 6 are 2 away. 6 is 4 plus 2. All even numbers are going to be 2 away from their previous even number because they are consecutive numbers. So we've got two consecutive even integers, and it's the sum of their squares that's equal to 164. So I'm going to square each of those integers, x and x plus 2, and I'm going to add them up, and that totals 164. So we've made this equation because we have two consecutive even integers, so they're 2 away from each other. We got x and x plus 2. We square them both. We set it equal to 164. Now we have an equation that we can solve. So I want to simplify, make this x squared, plus FOIL this guy out. We'll get x squared plus 2x plus 2x plus 4 equals 164. Combine our like terms. And I went ahead and moved that 164 over by subtracting. And now we can solve this however we want. So we could use the quadratic formula, we could use the square roots, but that's not really going to work for this one. I'm going to try to factor this out. So I've got a 2 on the outside plus a 2x minus 80. And now I want to think, if I factor this trinomial, then I need two things that multiply to be negative 80 and add to be positive 2. So I'm thinking 8 and 10 with a positive 10 and a minus 8. And then using our zero product property, remember that from 2 classes ago, the zero product property says I can set each one equal to 0. So x equals negative 10 and x equals positive 8. But we want to find two consecutive even integers. So actually, our final answer isn't going to be negative 10 and positive 8. It is negative 10 and negative 8 could be two consecutive even integers, or positive 8 and positive 10 could be two consecutive even integers, because that's how we set up this equation. So we have two possible answers to this problem. Number 11, this next word problem. A square is turned into a rectangle by decreasing one dimension by 5 and increasing the other by 2. The area of the new rectangle is 34 less than the square. Find the side of the original square. Whole lot of stuff going on. So I would start by drawing a square, because that seems like a reasonable thing to do. This square is going to be turned into a rectangle. So we don't know anything about the square, but I do know that squares have the same sides. So if I call x the width, then x is also the length. So that's kind of nice. It's the same thing. Now this square is going to turn into this rectangle because the top part is going to get smaller, and it's going to get smaller by decreasing by 5. So x minus 5. And then the other side is going to get longer by increasing by 2. So x plus 2. Then it says the area of the new rectangle. So this is our new rectangle. So the area of that would be to take the x minus 5 and multiply it by the x plus 2. So that's the area of our new rectangle. That is 34 less than the square. So is usually means equals. That area is 34 less than the square. So less than means the 34 comes at the back, so it's going to be x squared minus 34. Setting up this equation is mega difficult, but if you can take it piece by piece, you can get there. So we have this equation, and now our goal is to solve it, which of course is easier said than done. But let's FOIL out this left side. We get x squared plus 2x minus 5x minus 10 equals x squared minus 34. Remember, we need to get everything onto one side, so I'm going to subtract the x squared, and I'm going to add the 34. So then we have no more x squared, so that's kind of cool. We've got a negative 3x from combining these two. We've got a plus 24, and that equals 0. So really, I didn't need to get it equal to 0 at all because there's no squareds anymore, and this is just an Algebra 1 equation that we solved by isolating the x. So we get x equals 8. So x equals 8, that means that is one side, because that's how we set up this problem, where x was one of those sides. So that is the side of the original square. Done.